Hello everyone! Today I want to talk to you about data wrangling. What is data wrangling? Data wrangling is a fancy term for cleaning data, restructuring data, reformatting data, or reshaping data. Kind of the mundane tasks of working with data in R. Now, you might be thinking, well, that stuff doesn't sound very exciting. Do I really need to learn this? Yes, you do. A few years back, a major survey of data scientists showed that the average data scientist spends about 89% of their time doing data wrangling, and only about 10 to 11% of their time doing fun stuff like analyzing the data, visualizing the data, communicating the data. So cleaning data just takes an enormous amount of time, and this can be a misconception because people think of data science as kind of a hygienic field, right? Everything's digital, so it should just be easily and quickly formatted and put together in an easy to use way. No. I wish that were true. But more often than not, we have to do a lot of data cleaning, a lot of data standardization, getting it into the right format, getting it into the right shape in order to analyze it. So today we're going to work through some basics of data wrangling, but I want to start off with a few bigger kind of suggestions about coding in general. In one of my last videos, I talked about how R is kind of an open source community, and that's a great thing because it allows us to innovate and to produce many different tools to do many different things. Well, that also means that there's really no correct way to do something in R. In fact, with data wrangling alone, the kind of subject of this video, there are at least 3 or 4 or 5 major different paradigms for data wrangling, how to do this. So I want you to kind of relax the assumption that you are slowly accumulating little bits of knowledge and building until you know everything. Nobody knows everything. And so the wise thing to do is to kind of focus on learning how to learn and accept that there's no single right way to do stuff and kind of resist the temptation to memorize stuff. Why should you memorize stuff when the information is as far away as your fingertips in a Google search? And I promise you, the very best programmers I know do Google searches all day. So no correct way to code, resist the temptation to memorize stuff, and generally be patient with yourself as you navigate these kind of new ways of approaching learning. So far in this series of videos, we've been learning about base R. That is what we installed when we installed R and RStudio on your machine. Now, base R is great, it does a lot of fun stuff, but in general, most of us are going to want to start installing packages. Packages are kind of add-on functionality to R that extend its abilities. So a package might be used to visualize data. A package might be analyzed to use to do the kind of latest and greatest statistical modeling. Packages can do all sorts of stuff. And every time a package is added to R, we have to install it and load it. So we're going to go ahead and install our first package today. This is one of the most popular packages right now. It's called the tidyverse. And I'm over here in my R console. I'm going to open up a new R script. And to install a package in R, you have a few options, but the most popular way is to use the install.packages function here, which has come up with predictive text here. Now, to install a package, you need its name. So the one we're using is called the tidyverse. And I'm going to go ahead and hit Control Enter to begin that process. And while it's installing, I want to tell you a little bit about what the tidyverse is and why it's so great. So years ago, R had a pretty terrible reputation for being difficult to learn. And that's for a lot of different complicated reasons. The language itself is actually 20 or 30 years old. So over time, as more and more new people come in, there's kind of a resistance to changing things, because if you change things, then the kind of old timers get a little fidgety. And so one thing that happened in the last 5-6 years is that a group of developers, people who write add-on functionality to code, began to build this thing called the tidyverse. The tidyverse, broadly speaking, is trying to make R easier to learn, easier to use, and makes it easier to communicate the results of your analysis as well. So we'll be working with a few different packages in the tidyverse, and I'll be explaining how we use them to do not only data wrangling, and data cleaning, but also visualization, and to a lesser extent, some types of analysis. Okay, so the package is now installed. I know because all these messages that are telling me the package is being installed have now stopped. And you'll see here that there's this message here about where all the binary packages have been stored. Okay, what I want you to know is when you install a package, all that you're doing is installing .r scripts in a folder on your computer that your R session can then call to add on those functions. So anytime you want to look at the package you've installed, you can do that. The way to do that in R is to write .lib paths. And if I run this, it shows me the location on my computer. Here's the file path. This is the folders I have to navigate through to find where this package lives. We don't want to do that now because we need to learn more about programming in order to learn how to read these .r scripts. But I just wanted you to know that conceptually it's now on your computer and it's a .r script. Okay, so the next very important thing about using packages is we have to remember that we not only have to install them, but we also have to load them each time we want to use them. So we use install.packages to install the package, but then to load the package, we need to use the function library. And once we've installed a package, we can select it from here and we can hit Control Enter. And now we are loading the tidyverse. And RStudio will now know that we want to look for tools that are in the package called tidyverse on this computer. Okay, so remember, install once, but then every single time you use the package, you have to load it. So if you close RStudio, open it up again, you don't have to reinstall it. You don't have to run install.packages again. You just have to run library tidyverse. And to kind of remind yourself this, or if you're going to share your code with someone else and you want them to know that they need a package, I like to just comment out install packages up here, just so people know, what was done in your code. Okay, so we've installed it, we've loaded it, and now we're going to start to take a look at some data and get into the data wrangling. So I've got a file here, which will be linked on our website, that's called Apple Mobility Data. This is data I downloaded from Apple, the computer company, the maker of the iPhone. And it is data that describes how far people are going during the COVID-19 crisis in a lot of different places. So we could browse it in the same way we did with some of the other data sets we've looked at so far in our videos. And you can see here there's different regions. So here's Albania, Argentina, and then it's tracking both walking and driving. And then over here you can see the dates. And this is the average number of meters that people were traveling each day, I believe. Okay, so that's great. It looks like the same kind of data set we looked at in a previous video, but it's actually a little bit different. If I write the name of the data set here and just run this line of code, you'll see in the console I've got a summary of the data set. And you'll notice here it's called a tibble. A tibble is very, very similar to a data frame, but the tidyverse package uses tibbles because they're a little bit easier to work with and they're a little bit easier to browse. Browse means looking at it. So I can, just by writing out the name here, see that it's got 3,625 rows, 227 columns, and I can see what all the names of the variables are. And here I can also see what type of variable they are. CHR here stands for character or a string variable. So I know that these are going to be text and not numbers. So that's just kind of handy and nice to know. All right, so let's get into the data wrangling. So we've got this big giant set of data, and let's say we're scrolling through here and we see Brazil. And let's say we want to do some analysis, but we only want to look at Brazil and we don't want to look at the rest of this giant data set. So what we need to do is called subsetting the data frame. That just means breaking up a data frame into a smaller part. Now in the tidyverse, and specifically part of the tidyverse called dplyr, which is another package that gets installed when you install the tidyverse, you have a function called filter. Now, think of yourself making up a new package and a new function. You have to think carefully about how to name them. And filtering here kind of means like filter out one part of the data. So we're going to look at other functions like summarize and arrange and spread, and there's all these kinds of names that are just meant to try to communicate what's going on with the function. But it can be hard to communicate exactly what it is. So what you're probably going to want to do is refer to the many useful sites online for the tidyverse that give you an overview, cheat sheets, and stuff like that. Today I'm just going to show you kind of how they work, and you can look up others as you need them when you go along in computational social science. Okay, so let's try to isolate just the part of these data that have Brazil in them. So I'm going to start by writing filter. That's the name of the function we're using that does subsetting, breaks up the data into smaller parts. Now, one of the variables in there I saw when we looked at the data set is called region. And so what we want to do is filter this data set on the region variable, and we want the region to equal Brazil. So if I run that, in the console down here, it's outputted that data, but often we want to store it and do something else with it. So if we want to do that, we could create another object here. So here I've used this assignment operator, and now I'm assigning the subsetted data to become a new object, a tibble or data frame, called Brazil data. And now you'll see in my environment pane over here, Brazil underscore data has shown up. And if we look over here, we see we've got all the data for Brazil from this very large data set. Okay. Now, one thing I want to note here is anytime the variable has a character value, remember you have to put it in parentheses here. And also note that I use 2 equal marks here. We do that because if we write equal, R can assume we're doing an operation. We want to look for something that equals a number or has a kind of a mathematical meaning. Here, equal says, find me exactly this thing that has a specific value. It's a little bit different. So just look out for that equal. If I take that away, you'll see sometimes I get some very unuseful error messages. We saw that in some previous videos, but you'll notice the people who build tidyverse have actually built in a nice error message that says, this usually means that you've used 1 equal sign instead of 2. Okay, so that's how we filter our data. Okay, now that's a good way to get the rows of the data that we want. We wanted to get all the rows of the data that are about Brazil. But now what if we want a column of the data? So not one of the rows, but one of the columns. Let's say, for example, that we want to get the column called region. That's the one that we use to find Brazil. Well, I could create another object here. I'll call it regions. Now, instead of using filter, which helps me choose rows, I'm going to use select, which helps me choose columns. I'm going to choose Apple data. That's the data set we've been working with all along. And I'm going to choose region. And now you'll see I have another data frame that has 3,625 rows, just like Apple data, but instead of having 227 rows here, it just has 1, and it has all the regions in there. Okay, so this is kind of basics on breaking the data set into smaller parts. Now, very often we might want to do something a little bit more sophisticated, like maybe we want to look at these transportation types here and say how many different kinds of transportation types are in these data. This is something we might do when we first open a data set. We're just trying to make sense of it, what's in there. Okay, so transport types, and then I'm going to use a function called count, and then I'll use Apple data, and then I'll choose another variable within there, and you'll see that RStudio has once again usefully sensed that I'm in this data set, and so I probably am looking for a variable there, and so I can just do the predictive text to let me choose it there. Okay, looks like I typed it wrong. Aha, I added an S. So I take that off. Transport type. Ah, transportation type. Right. Okay, that's a useful, teachable example though, right? See how easy it is to mess up the spelling or something, or use a capital letter or something like that. Believe it or not, I will admit publicly to having spent minutes, and I mean minutes, staring at a line of code and not being able to do what just took me 30 seconds to do. So if you do this, totally normal, don't feel bad about yourself. Okay, now suppose we want to find some part of the data that is, I don't know, let's say at the beginning of the alphabet. We could arrange or sort our data set using the arrange function. So I'll call it alpha order for alphabetical order. Now I'm going to write arrange. That's a function that lets us sort the data frame. And I'll do Apple data again. And this time I'll arrange it by region, which is the names of the different countries here. And so now I've created a new data frame that is now sorted. So it's in a different order with the alphabetical order defining the order of the regions in the data set. Okay. So this is good, right? We can break up the data into little pieces. And if we wanted to figure out things like what was the mobility rate in Brazil on March 23rd, 2001, we could come up here and click on Brazil and scroll all the way over and find the date we want, right? We could do that. And that's fine if we have a small little bit of data, but let's say we wanted to do this again and again in different ways and kind of, or make sense globally of what's going on here. Now, if we want to find out, for example, where are people being the most mobile or the least mobile? Where are people social distancing the most or sheltering at home the most? Then we need to kind of restructure our data. What we need to do is move from this data set, which has a wide structure, meaning we have quite a lot of different columns. We have all these different dates up here, right? To what's called a long data set. So wide means lots of columns, long means lots of rows. In this case, what we'd like to do in order to calculate the maximum and the minimum rate of mobility here is we'd love to have all of these data, right? We'd like to calculate it by country, by transportation type, but we don't want to have days as additional columns. We just want to have a column that says value and then a column that says day. And then we can look across all days at once to calculate the maximum day or the minimum day. There would be other ways of doing this as well. This is just kind of a workable example. So bear with me as we kind of try to wrap our heads around this somewhat complicated process of reshaping data. Again, moving from wide data to long data. To do this, we're going to use a function called gather. First, I'm going to create a new object. I'm going to call it long Apple data. Then I'm going to use the gather function here. And with the gather function, I'm going to put in the name of our data. And then I have to give the gather function two things. I have to tell it what I want to be the key. That's going to be the name assigned to all those date variables that we're going to change into one long row instead of lots of wide rows. So I'm going to call it day because those happen to be days, right? And then the other thing I need here is to give the new variable we're going to create here, which is currently in those cells of the data frame that are all underneath the date. I need to give it a name, so I'm going to call it mobility data. Create a little more room here just to see what's going on. Okay. And now what I need to do is a little bit complicated. I need to tell it the range of the variables that I want to be removed from the wide data set and added to the long data set. So in this case, the rows happen to be all these dates. Now this is a little bit annoying, but dates behave a little strangely in R. So I would love to just be able to write this, 2002, 01, and what was it? January 10th, January 13th, okay? But as you see here, RStudio has made these a different color, and that tells me that it's thinking of these as numbers and as kind of units that it's trying to do some operation on here. So subtract 1 from 2020, right? And we don't want it to do that. Now, you might think that I could just put it in quotation marks because that's typically what we do with character variables. but that actually makes R think it's a character variable and not the name of a column. So in order to tell it what to do, we have to use the backtick key, which is just to the left of your 1 on your keyboard. And I'm going to tell it the first number we want it to use, and then the last number we want it to use. And in this data set, the data end on, I have to use another backtick here, 2020, 08, 20. I'm just going to close my parentheses here. Wow, that's a long line of code. And now that we've run that, you couldn't see it over here until I come over here, you'll see now we have a new data set called long_apple. And instead of having 3,625 rows and 227 variables, it's got 801,000 and change rows and 8 variables. So when we take a look at that, you'll see here we have the same thing, our countries and our transportation type. Then we have a new variable we created called day, and then we have this mobility data. But that's all that we have. So now what's nice is we can run some simple calculations to look at the maximum and minimum, say, mobility data. In a previous class, we used the mean function to look that up. I'm just going to go ahead and click here to sort this data frame in the data browser to find that the place with the lowest mobility rate during the entire coronavirus period, at least according to Apple. And remember, we should think carefully about who's using Apple and whether that's a reasonable approximation of the place we're studying, right? It could be iPhones are expensive, so it could mean that this is only really estimating mobility among more wealthy segments of different countries. But with that caveat aside, we see here that Sevilla in Spain had the lowest mobility rate, and the highest mobility rate, Currituck County in North Carolina. So there you have it. We've done some basic data wrangling today. I went over a little bit of the philosophy of how to work with many different choices. We today focused on the tidyverse. We're going to continue to use the tidyverse throughout these videos, simply because it's kind of a one-stop shop to do lots of great stuff. So see you next time.